Alright, time for a draftphysics.com video presentation. Debatephysics.com also. This is essentially a follow-up to the previous Professor Lewin is as dumb as a flat earther or whatever. Just exchanging a compliment. Sorry, you're as wrong as. But anyway, and just providing more proof. More evidence, blah, 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 blah. So I'll put it on YouTube, and then I'll go back to my regular video production schedule, blah, blah, blah. Very strange kind of view numbers, right? 273, yet only 15 thumbs up. Now, there might be a ton of thumbs down, but I think it's just the fact that these are all just nothing views. You know, people are just coming back to check their comment or something and see if anybody replied or some kind of crap like that. So they're really empty views, sadly. I did post a link on Professor Lewin's video, but he does what I do rationally. He screens the comments. And I guess he just didn't screen comments yesterday, so can't see if he deleted it or if he saw it or any of that crap. But whatever, not a big deal. So of course, a couple of, frankly, I'm just so sick of you people, I just call you what you are, which is jerks. Okay, I'll say jerk. You know, they just do these irrational crapola of keep defending the nonsense. So I'm not sure about elasticity or how much energy would be lost to heat. So the whole point of doing the experiment specific ways is to reduce all the losses you can. And they're a tiny percentage they end up. In the example I'll show, there's a tiny percentage of losses. It really doesn't leave at half the speed kind of thing. It leaves a little bit slower. But it's tiny. So just keep playing games at this dramatic. I mean, frankly, this is dramatically not half. All right, I mean, this middle number should be, frankly, it should be a lot less than half. It should be going slower than half the speed. It weighs twice as much. In an ideal circumstance, it goes half the speed. In this circumstance, something else is going this way, which means the energy, right, is now less. And so it should be going much less than half. Well, it's going much faster than half. This isn't heat. You know, heat doesn't make more energy. Well, I point out. But if you check this video again, 4 minutes, he clearly states you can't have more energy after the collision. It all just understands, you know, it's based on what you think energy is. So as I try to keep doing is I try to get you people to understand that, all right, we got motion in a direction. Yeah, okay, you have some idea that somehow the motion cancels or something. Now, you know, two trains don't cancel. The motion gets converted into a bunch of stuff flying in all kinds of directions. So it really doesn't cancel in any way. It's real motion. It's real heat. If I let the trains go this way, they will eventually create heat in the environment, slow down, right? If I don't keep them going, right? They'll heat the tracks. They'll go quite a distance. If I crash them into each other, same amount of heat, okay? There's not going to be a different amount. It'll be exactly the same amount if they didn't crash. If they crash, they will dissipate to the environment their energy. They will give it away. They only have so much to give away, and it doesn't matter what direction it's going. So if you think about it like heat, you wouldn't say, I can have 30 watts go that way and 130 watts go that way, and that only equals 100 watts. If it was heat, you'd understand, you know. And it is heat. A joule is a watt. So, I mean, yeah, I mean, there's a point where, right, I just say you're belligerently an asshole. You belligerently defend, you know, whatever the Pope says. You're just like some Catholic fanatic. The Pope is the holy man. Blah, 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 blah. He has a ring with 400 slobbery diseases on it. Doesn't that prove he's God? Because he doesn't, well, you know, they do get sick and die, don't they? Anyway, what do you want me to say? Okay, you're just making crap up to believe. Okay, period. Religious fanatic. Yeah. So I tried to explain, but you know what? Why waste typing this crap? So I'm starting all the comments with, as usual is the case, you have ignored all the arguments made in the video. So I show the lever, I show the space thing, I show all this stuff. Doesn't matter, because these people are belligerently assholes. Okay, as to the nonsense regarding checking the video again, you should check it again for the part where he says momentum must be conserved, right? So the argument isn't rhetoric. The argument is theory, okay? They say things like, its energy is conserved. And then they show you an experiment where there's no conservation. I'm just saying that what they say doesn't mean anything because they don't even have any strict definition for anything. All right. Well, I'm just not gonna, I won't bother reading my responses. Hell with that. So then this Liska guy does the same crap. Using correct numbers could help people see that 3 minus 333 and 133 sum up to 100. And again, so that's based on what kind of logic? And I pointed this out, so there wasn't any doubt that I was making it quite clear, all right, that, I gave another example, and I said, well, if I had 100 momentums come up this way, and 200 went that way, and 100 went that way, does that mean only 100 is in the system? Of course not. So I used another example, but I'm clearly not running in any way from you understanding that they're basically pretending that because it went back this way, it undoes the extra momentum that went this way, which is stupid and ludicrous and moronic. Again, you wouldn't expect two trains that have a total energy, right? I could leave one train not moving, one train moving. You wouldn't think it would be logical in that wreck to think that, well, the wreck will have 166 momentums in it. Why would you think that? That would be really stupid. It only has what goes in. The numbers have to add up. The before number has to be the same as the after number, accounting for all the whatever losses there were to the environment, of course. And the whole point of doing the experiment in these, funny ways, air tracks and such, is to eliminate as much as the unseen losses as possible. Shit. And then he says, perpetual motion, did you consider the movement of smaller objects into opposite directions, into the opposite directions? What are you talking about? What smaller motions? What are you talking? So I just said, I don't even know what the fuck you're talking about. And anyway, another thing about the perpetual motion machine, wouldn't the largest object on the upper row give the smallest object on the lower row the same motion as the smallest first object on the upper row? The whole point is right, as you're going this way, I don't know, draw it, is it worth the trouble? You people are just so dumb. There's, you're not even trying to get it. Same motion as the smallest on the upper row initially, in the opposite direction. Where has alleged extra energy come from after the full revolution? So he's just denying the whole the whole argument is just lost on this moron. Yeah, maybe I'll pause to go to the other. Well, anyway, let's do the playlist since we're here in the comments, and then we can get to the newer videos and whatnot. All right, so this guy posted a playlist. Now, it's got a lot of crap in it, okay? And he just leaves a comment, I made a playlist. He could have posted the link. I really think the link would have posted, but whatever. So I posted a link to the playlist. And I point out that most have no actual data connection. So it's like 40-second videos of just the collision. And from camera angles that you can't even, as a practical matter, isn't very useful. Anyway, some of it. And some of it's just so sloppy. It's like a Brozo video. It's of no value. I will go through them and see if I can ascertain the actual velocities. So the good news is the first link was actually a video I've seen before, and I just didn't realize that in one of the segments they did the experiment I was looking for. So, pretty much. So it's the Arbor Scientific video. And, it conclusively shows very different results than Professor Lewin's. So I will go over that. Now, these numbers I put here are probably a little bit off, but anyway. we'll go over it. And, I mean, you can see it visually. You can see it in another one of Professor Lewin's own videos. So I'll go over that also. So leave us go to, yes, first I'm going to do the perpetual motion machine one more time. And it really, what's the point? I shouldn't read any of the comments because they're just a distraction. People are just not even trying to be intelligent. Alright, should be back. And hopefully, yeah, this is the drawing position. Okay, so you have a one mass object collides into a two mass object. Now see, I think you can do this with just pendulums, okay? You know, you put two strings on the pendulums, keep them in the same position, and, you know, accomplish the task. Alright, and then this, and then this. So you're basically just saying I have a 1 mass. You could use a half mass and then a 1 mass, right? You could use 2 ounces, 4 ounces, blah, 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 blah. So you got a 2 mass, you got a 4 mass, you got an 8 mass. Alright, and they bang into each other. And with each time they bang into each other, their momentum is increasing. So you have 100 momentums here, right? You have 130 here. You have let's see, the next interaction is another, it's a little more than 30, so let's just make it 66, and you know, and then we can make this to 200 just to finish it off. So you have 200 momentum by the time you get here. Now it's moving much slower, okay, so its velocity has declined, but the mass has increased, okay, so that's the part to understand. So the real momentum is 200. If you used the word joules to describe momentums, you went from 100 to 200 joules. If it was watts, okay, you had started with 100 watts. You now have 200 watts. Okay, you just have a different kind of voltage to amperage. You know, instead of 10 volts and 5 amp or 10 amps, you know, you have 5 and 20. You know, you have a different relationship, but you have actually more energy. That's the fact. And then you just take a simple lever, all right, you know, little plungers on it or whatever you need to make it work properly, and then you just hit the, you know, so you put the lighter mass, the 1, okay, back down here, but you put it further on the lever, so I didn't draw this lever exactly the way you need to. So here would be to say the fulcrum of the lever. So the heavy thing goes in this side, the light thing comes out further away down the lever, right? Maybe, you know, take twice or 3 times the distance because you have more. And the fact is that this will swing with the 200 watts of energy, and it'll give this the 200 watts this time. So instead of 100 watts, instead of a velocity of 10, okay, it's going to have a velocity of 20 this time. So it's going to start with 200. And then it's going to do the same thing for 2, 4, and then 8. Same thing, and then you just have a lever on this side, and the same thing is going to keep happening, right? So the fulcrum is here. This is going to convert the slower velocity into the faster, you know, again. So it's, you went from 20, you have a starting of 20. Now you're going to have a starting of 30, and then you're going to have a starting of 40, and then you're going to have a starting of 50. It's just going to keep going higher and higher. It's going to gain more and more speed. You could drain off some of that pressure by not letting the lever swing all the way, and then you could charge a battery or something. The perpetual motion machine would just keep going, and it would keep charging your battery, blah, blah, blah. Perpetual motion machine, free energy machine, blah, 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 blah. All right. This camera's a little bit off, I think. You can't quite see the board entirely. All right, close enough, though. All right, so let's go to the same Professor Lewin video, okay, is the one showing I just showed with the 3 counters and the, you know, crazy number for the 2 mass object. Okay, so the 2 mass object had a velocity of 182 or whatever it was, right? This number was pretty much the same. It was 120 something instead of 111, but pretty close. So it was moving a little bit faster in the previous experiment, and clearly the two-mass object was going way too fast, way more than half the speed. Now in this experiment he had an error, right? So now he's doing an inelastic collision. So he wants the cars to stick together, and they don't. It fails to stick. It bounces instead. And what you end up with is the little cart ends up still moving a little bit forward, but the big car is a lot less than half, right? So it's the number should be for half would be 222, and it's 275. So it's 50, almost a quarter, or fifth, slower than half. So nowhere near 2/3. It's more closer to 1/3. All right. So that's a real elastic collision. Now, it's not what their math says the result should be. So their little magical math says it should be something different. So that's why it came out different when he's doing the experiment, is because they forced it to come out consistent with their holy math. All right, the holy book says, and therefore they have to make Jesus, walk on the water. So they figure out some way to put, levitators under his feet or balloons or something so he can look like he's walked on the water. But when he accidentally does the real experiment, it comes out much slower than half the speed, not much faster than half the speed. So, I can just play this little clip and then you'll get that. Probably get a commercial for...
You ready? There we go. Oh, you see they bounced.
Yeah, they hit each other and didn't stick, and therefore they elasticated. And like I said, so in a pure elastic collision, it ends up being slower than half the speed. Not faster than half, slower than half. All right, so now we can go to the Arbor Scientific video. And where you can actually measure, because they do have a tape measure. Now maybe you're not going to be able to see it quite as well as I was or am, and that's unfortunate. Now what you will notice, I'll play it for this little bit. See the fingers on what we assume to be a two-mass object. Now it doesn't really matter what the mass is. The argument is that the total momentum is going to be conserved. That is, you can't make any more momentum in any direction. Doesn't matter what direction anything's traveling. You can just add up the arrows and it'll come out. So you can just figure out velocities based on just frame by frame analysis. But I'll just play this little bit so you see. So watch where the two little fingers are. So they were holding it because now this is the company that makes the air track, and apparently they couldn't get it level, which is kind of funny. So the two mass object's actually drifting a little. So you have to take that into account. Which just makes it a little more complicated, but it doesn't change the basic rules any. Alright, so this one is actually, you go and see it, it's actually moving. But by doing frame by frame, right, you can see this one's actually moving. And so you can come up with numbers for each one of these movements. Whoops, I didn't want to do that. Frame by frame. Alright, so frame by frame, this one's actually moving a ½ centimeter per frame. So a half notch on the ruler per frame. So it's 0.5. And this one is moving really slow, so it's almost 10. So 10 divisions per, so a frame is 1/10 of a division. Now it's twice the mass, so you have to understand you have to double that number, so it would be 0.2, because it's twice the mass moving at 0.1 division. So to make it the same as the other one, you have to double it. So this one's going 0.5, this one's going 0.2 in the opposite direction, so you have a total energy of 0.7. Alright, and now you just let the collision happen and do the same kind of counting. Alright, so the collision happens, and what's happening afterwards is now this one's 0.3. It's a little more than that in divisions. Okay, so this one's 0.3, and then this one is 0.6. Closer to 0.7 actually, but 0.6, so it's again much slower. So you understand the initial speed coming in was 0.5. The speed of the two mass object isn't anywhere near half, right? I mean, half would be 0.4. It's way at 0.6, close to 0.7. So not even close to half the speed. So it's going away much slower than half the speed. All right. And but remember, you have to double it, so it ends up being 0.15. You have to double it. Or 1.4, sorry. Could be 6 would be 12, right? 6 doubled would be 12. 7 doubled, 14. All right, and now you just add up those numbers, right? So you could just say that if this is 0.3 and this is 0.1 could be 0.16. All right, so you'd end up with a total. This is more than 3, so let's just a little bit more. So 33, let's say. 33.33 plus, okay, 0.17 would end up being what you're looking for, which is point. Right? Well, I should have just done it on the board. I'll do the math on the board. That's a good idea. So I'll be back in a minute. Yeah, I should be back. And you should be able to see most of that, right? I could slide that over a little more. And cut me off a little. Yeah, we don't need me. Well, I could also slide this over here. Alright, that works fine, I think. So you should be able to see it in one of the two boards anyway. Alright, so the 1 mass, the 2 mass. And it doesn't really matter if it's exactly 1 and 2. But anyway, so the 1 mass, if you count the divisions, it's pretty much exactly half a centimeter. So per frame, it moves 1/2 of a centimeter. So 2 divisions, right? We're gonna call a division the half centimeter, and so it's 2 divisions of a centimeter, which equals 0.5 of a centimeter. The 2 mass object, which is just drifting very slowly, so it's 10 divisions, which is 0.1, but it's twice the mass, so you have to double that number, because the real momentum is going to be twice that because you're doubling the mass. So it's 0.2. So 0.5 plus 0.2 equals a total of 0.7 divisions of momentum. That's what you have as a total of movement before. After the collision, you have the small object leaving with 3 plus divisions. Okay, pretty much it's a little more than 3. Which comes out mathematically to say something like 0.36, a little bit more than a third, as the number of division, as the amount of distance. And the big object is going 7 divisions. Okay, so 1/7 of a centimeter per frame. So you go 1 frame, 2 frames, 7 frames before you get to the centimeter. 3 frames here, 2 frames there. You're just counting the frame numbers essentially to move. So it's 7 frames, divisions, which converts 7 into, just do the 7 into 10 thing, and it's 1.6, and again it's twice as massive, so you have to multiply it by 2 and you get 32. So then you add up 36 going this way, 32 going that way, equals 60.68. So it's a little bit of a loss, right? So it perfectly fits in the sense that yes, the collision heated the little spring a little bit, the air resistance, blah blah blah, you got 2% losses to the environment. So perfectly consistent with conservation of real momentum. And momentum doesn't care which way arrows are going. You don't cancel momentum because you're going this way. This way doesn't cancel that way. Never happens. Train wrecks. Anyway, so I don't think you need any more than that. So you can test it for yourself, blah, 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 blah. But, I mean, I'll show it in the video. You can see it's going clearly, the 2 mass object leaves going much, much slower than half the original velocity. Much slower than half the original velocity. 7 divisions versus 2 divisions. 7 frames to go 1 centimeter versus 2 frames to go 1 centimeter. clearly a lot slower. Clearly not 3/4 of this. Clearly not 3/4 would be around 3 divisions. Clearly not 3 divisions. Twice as much as 3 divisions. Clearly not the same result as Professor Lewin's experiment. So at minimum, you have 2 very conflicting experiments done under circumstances you would say or have some integrity. I mean, Arbor Scientific makes air tracks. It's their business. Apparently they don't make, kinetic energy formulas, and they don't know that they were supposed to show the results being entirely different. But anyway, so what's the reasonable conclusion? That Arbor Scientific faked the results in the wrong direction, trying to prove science wrong? Or maybe the science in Professor Lewin's video isn't right? Which is more realistic? So we will play this again, frame by frame. So now they're leaving. Now, if you count for yourself, you can see, okay, that the first cart's on the 4, the other cart's a little bit before the 1. Okay, and so we'll go 1 frame, 2 frames, 3 frames. You can see that the first cart has in 3 frames, it's going a little bit faster than 1/3 a frame. And the other cart has barely gotten anywhere, right? 3 frames, and we're not even halfway across the division yet. It started right before the 1. It's not, it's dragging along. So we got 3, 4, 5, 6, at least 6. I'd say 7, but anyway, I said 6.5 pretty much, and well, it's close. Okay. So all you're talking about is a number, the 68 will go to 67, or it'll go to, the other direction, 69. But, so that's the truth. Way slower than 2 divisions. 7 divisions, 2 divisions. Velocity is way below half the speed. Way below. Way below. So, so I can play this again. There are 3 divisions for the other one. Same thing. It just happens over and over again. You can just do the count. Let's get to a 4 here. So we're right after the 4. The camera angle is a little off, so we want to go a little bit past the 5. So it's 1, 2, 3, 4, 5, 6. Okay, 6 is probably the right answer. So 6 into is 16. Yeah, so that's exactly what I did 6. So in spite of the fact that I wrote a 7, I did 6. All right. So what do you need? How many times does it have to be shown that this doesn't make any sense, that Professor Lewin's experiment is not consistent with logic and reasoning? This one happens to be, nice ruler here, blah, 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 blah. So it's all very helpful. But you clearly have evidence. So the argument has to be that somehow Arbor Scientific did this experiment wrong, even though they make air tracks. Now it's clear, they couldn't even get their track leveled, which is kind of bogus. But I accounted for that, and it's not a mistake on my part. It's been accounted for. The drift speed of the 2-mass object was accounted for. All right, so I guess what I'll do is I'll think about what I'll do. I could play this. There's no point in playing it again, right? But I'll play it one more time, just. So you see that this is Professor Lewin. He's going to make a mistake, all right, and that's the truth. It's just and the mistake reveals the truth.
I will set them again to 0, and now we get 1 onto double the mass. We ready? There we go. Oh,
yeah. So you see it right there. A lot slower than half. Half would be 2, 2, 2. It's a lot slower than half. A lot slower. 50 units slower. So I really shouldn't have to continue to keep making this argument. Clearly that's what an elastic collision does. And this fable that somehow you make more energy is a fable. Okay, so now I'll do a little bit on another train of proof or logic to attempt to convince you of how it really works. What am I trying to find here? Yeah, we'll pause. Clean. Alright, should be back. Alright, so we'll start. Yeah, I don't need that. So that's close enough, I think. Alright, so let's just start with a immovable object. Okay, so this is immovable, been bolted to the ground. Alright, and now you're going to take your one mass cart with your, say, 100 momentums. We'll just make it simple. Alright, and it's going to crash into it with its little spring. Okay, you logically know it's coming back with the same energy you put in. Right, you crash it in, it doesn't come back with 165 momentums. It goes in with 100, it comes back out with 100, right? So we should all be able to agree on that. The immovable object will not take any of the energy. Okay, the spring might take a little, this, that, and the other thing, but this won't take any of the energy. So now let's make it so it's just starting to be movable. So this time, when I crash it in, so let's just use this as always the starting thing, and I'm just going to give it a little bit more mobility in each thing. So this time it will move a little bit, and we'll draw moving a little bit. Well, we'll put an arrow in. Okay, an arrow that big, so it moves a little bit. So you know that this now isn't going to come back with 100. Okay, so whatever the velocity is, it's going to be something less now. Okay, the velocity, let's make the velocity 100, and we'll make the mass 1, and that'll make it easy, right? So you know that it's velocity coming back, okay, this time, going this way, all right, that it's going to come back with something less than, okay, something less than 100, right? So whatever this takes, so let's say this moves just 2 velocities. Okay, and it has a mass of, well, I don't want to make it too confusing. Let's just say it has a 2 mass. You sort of might have to make it a bigger mass, right? Because it can't move as much. It has to move very little. So we'll make it a 10. All right, and it has a very little velocity. But the real momentum is going to be something. So let's just say the momentum is 20. Should have made it 10, right? So it's only taking 10 of the momentum. So however you want to arrange its mass to velocity, that's fine, to come up with 10, right? So then you know this has got 90. All right, so 90 of it's going this way, 10 of it's going to go that way, right? And I can just keep increasing it by making this more and more mobile, right? So the next time it takes 40. Okay, well then you know, 40, longer arrow, you know that there's only 60 could possibly be going this way, right? So you know the velocity has dropped. And, you know, I can just keep doing that, right? And you can understand that, yeah, I can just keep doing this until I get to a purely elastic, that is, I get to 1 mass. So I'll drop the mass incrementally, right? And eventually I'm going to get to 1 mass here, and 1 mass here. And you know what you're going to get, right? You know that this one's going to hit this one's going to leave with 100, this one's going to stop dead and lose all of it. So it'll have 100 going in, all right? It'll lose it all, give it all to this thing, and it'll be 100 going out. So you know that's the progression. So why should there be some argument that if I have 2 here, if I have a 2 mass here, that all of a sudden some strange shit happens where this leaves with 130 momentums, and this goes back this way with, you know, 30. Well, 33, whatever, to be precise. Why would you, isn't that just totally irregular? I mean, every other experiment, you know it's going to come out this way. You know this end one, you get 100 back. You don't get more. And you know this one, You get 100 forward this way. You know those are the two endpoints. How can you have something in the middle there that's doing this when you know it has to work out? So right here, Professor Lewin's experiment sticks out like, what do you mean? How could that possibly be consistent with, it's not consistent with all the other experiments that are just like it. The 3-mass experiment or the 1-mass experiment. It's behaving completely irregular to all the other experiments. Why? Is it magic? Come on. So, you know, again, this isn't chess. This is pretty checkery. You know, this isn't. I mean, the idea that I'm trying to explain here isn't that complicated. 100 goes in, 100 comes out. Okay, 100 goes in, 100 comes out. How do you do this? You know, 130 comes out, and 30 more over here. How do you get 160? Come on. I mean, come on. And that's right in the core of physics. All right, is their inability to recognize this simple, that doesn't make any sense. And I've explained to you the absolutely horrible history, invented by a religious kook, a guy who overtly said Newton and Descartes are two atheists. Their physics is too atheist. So overtly how he described it. Okay? It was MV. It wasn't 1/2 MV squared, so it was getting completely wrong answers. He had no physical experiments to defend what he was saying. He just said, your theory isn't my theory. You know, he says, you people don't believe in conservation because you're not conserving my magical, V squared, my MV squared. No physical experiments. He dies nothing. Okay, it's resurrected by a French woman with money. Okay, who, you know, has parties, you know, does little show experiments, kind of like a Tesla-esque kind of person, right? You know, not, you know, I won't say Tesla wasn't a real scientist, but again, it was, you know, it was all kind of show science and BS. So she does this show stuff with little clay experiments, right, and dropping stuff in sand. Perfectly understandable experiments in the sense that you're quote mining the evidence, right? There's the lever experiments that don't show this. There's spring experiments don't show this. Other experiments don't show this. So they just engineer the experiments that look the way they want them to look. So it's completely Ken Wheeler-esque ferrocell bullshit. You know, I'm going to convince you that light is bent by magnets with a bullshit gimmick. So gimmick experiments. I mean, they're just really poor experiments. I could do exactly the same experiment, use cornstarch, liquid cornstarch, and I'll get exactly the opposite. And I'll create a justification for you believing m squared v, okay? Because you'll have exactly the opposite results. So just no integrity at all. And then in the 1800s, they do some bullshit where they say, Newton said F equals ma when he didn't say that. And then they say work equals distance when now work is about how much time you're opposing a force, not how far you go opposing the force. Right now you're technically not going anywhere. You're sitting in your chair and it appears like you're not moving. Fact is, though, you are moving because you're pushing into the earth, and that's why it's pushing you back. Because you actually did move into it, and it actually did move you back out. Those events actually are taking place. That's real science, okay? This is bullshit. So there's no evidence for it. They just keep proclaiming it. They'll tell you that it takes 4 times more gas to go twice the speed. No experimental evidence. And this, and how much evidence do you need? What do you need to be convinced? I mean, the rocket ship example. I throw a dime going 1,000 miles an hour out one side of my ship, and I throw 2 liters, 2 kilograms, 1,000 times more atoms out the ship going 1 mile an hour out the other side. It's still atom per atom, $1 per atom, so to speak. Why do you think the ship's going to go, jet in the other direction? There's 2,000 watts of energy on one side and only 2 watts of energy on the other side? You really believe that? Again, it's not chess. You're failing to get the concept of checkers here. The evidence is in checker form. You really should be able to follow the motion of the pieces. Okay, you don't have to do some, think way into the future. You don't have to do any complicated thinking to figure out that this theory is garbage. Alright, well, whatever. Yeah, I've done all I can do. All I can do is reason with you. If you're not reasonable, that's not my fault. So you're not subject to reasoning. You don't get the concept. There's no evidence. There's no good reason to believe, and there is in fact very good reason not to believe. Extremely good reason. The unification of energy. All right, just get rid of your mv squared, and what happens? Well, then all of a sudden, weight and pressure and heat and work and energy and force all become the same thing. Equal signs for all. Makes it all really simple. So anyway. Yeah, well, there's nothing. I mean, just the whole context. Newton just sit there, Newton just gives you an explanation of the motion of everything that we could see with a telescope. He gives you a method of viewing it and understanding exactly where it's going, and it's all based on momentum. He gets perfectly right answers, and you think there was a good reason to fix what he was doing. That somehow we needed Leibniz to give us some new theory because that theory didn't work. No, that theory worked perfectly. Descartes got correct answers. Descartes would tell you what things banging into each other, what the end products are going to be. He wasn't wrong. There's nobody who proves Descartes wrong. Leibniz just says he's wrong. That's all he does. He shows up and says Descartes wrong because his answers aren't my answers. He doesn't show you an experiment that demonstrates Descartes got it wrong. Oh, man. Just so bad. All right. Just, yeah, that's the point where I'll have to give up on the idea that people have any integrity whatsoever. That they all are just little balls of absolute lying suck. Because if smart people can't do this, what hope is there? Ugh. Shit. That's all. Alright. This has been a draftphysics.com video presentation. Anybody, inviting anyone to be able to, you can make a Skype call. I'll call your regular telephone number. That's fine. So if you can't do video, anyone willing to defend, make an argument where you account for all the arguments I've made. The lever, the spaceship, even this, the brick wall. They all reveal the truth. And it's not what you're selling. All right, so I'll leave again. All right, so till the next time and such, this has been a draftphysics.com video presentation. La, 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 la.